hi there. I didn't see you. I went to get more tea. Good morning. We're still standing by for 30 more seconds. Henry, welcome aboard. Unconformable Coatings, welcome aboard. Amir, welcome aboard. Tuck, who's like still digging out from snow, right? We got Mr. Blodgett on the YouTubes, and Wes is standing by. 3, 2, 1. Click. It's top of the hour. You're welcome. So nice to see y'all. I have some things for you today. How y'all doing? Danny, hello. How are you? Thinking of you today a little bit. Bob Labs, welcome aboard. John Hopper, welcome. Can I get an audio report on the YouTubes? And good question there, Henry. Today it's pretty standard. It's English breakfast tea. I buy English breakfast tea in bulk from Davidson's on Amazon. Mr. Blodgett is playing with both hands, probably to give me a good audio report. Thank you for being... And Mr. Blodgett, I've been thinking about you. I'm going to hit your project soon. Something's happening back there. Oh, my grinder is warming up. That's what it is. So we had a fun, busy, early weekend of grinding, and I will tell you all about it. Henry says audio's good. Mr. Blodgett is not complaining on the YouTube, so I'm assuming that the audio is good. So here we are. Welcome aboard. Bunch of stuff to report to you. We're going to, first of all, we got to talk about the contest. And we have a contest winner to announce. I hope he's here today. That would be cool. I don't see him here, unless I don't know his nickname. We're going to talk about my chuck grinding experience, which was excellent. We will talk about back orders, which I hate. And we'll talk a little bit about Cryo. So, Cryo is starting to get understood better. And here's Bart. Welcome aboard, sir. Cryo is starting to get understood better by me. And I'm pretty excited about trying it next. And I have an idea for the next project, which is going to get heat treated and cryoed. And that's going to serve as a platform for further experimentation. So if you haven't figured it out yet, all this stuff is helping us learn things. One thing I was hoping to do for today, but I never got around to, was doing a hardness test on the final Crisco gauges. But I did not get a chance to do that. So I will report that on the social medias. Danny Bradley says, I have chuck envy. Don't worry, Danny. By the end of today, you will understand how to grind a chuck. It's one of those things that, there's a lot of information out there, and some of it's contradictory, and I think I've fallen on a recipe that just works. It's not quite all the way to what Robin Renzetti was recommending. It's almost there. We'll talk about it. And it's definitely not what others have done. But I think it works. I think it works good. It's not expensive. It's cheap. And like that. Do I have a surface roughness tester? Yes. Yes, I do. Would you like me to test the as ground chuck for surface roughness? I think that's not a bad idea. So, okay, let's get the contest winner out of the way, because you're already having me spin off the road into a whole nother topic here. So all systems are working here, right? I'm checking everything. No drop frames. Everything's good. Okay, yeah, Henry, I will report back to you. In fact, I'm taking a note right now to measure my achieved RA on the chuck. Okay? We're going to talk about why that's not terribly important, but actually your question is good, because it puts a number on a result, and that's measurable. So I totally dig it. I don't think it's important for the application, but we will take care of you. So, contest winner. Let's get the administrative stuff out of the way. I got a list of all the entrants, and 2 weeks ago, Claudio, bienvenido. MX Peter, welcome aboard. As good as can be expected. So 2 weeks ago, we announced the winner. I announced the winner on the YouTube Live, on the Instagram Live. I did an email, because I had this person's email from placing an order with me, and I've come up totally dry, no contact. So after 2 weeks, I'm going to the next person in line on the contest, very close. You may recall, do I have the official piece of paper here? Yeah. The official count of the boxes in the bag was 396. You guys on Instagram just have to sort of mentally imagine turning those around. Metric Chris, welcome aboard. Or should I say, Millie Milk, welcome aboard. I couldn't even do that. AM Metals, welcome aboard, sir. You sound very familiar. So 396 was the magic number. The now next best guess, which is being awarded the prize for the contest, is Mr. Jeff Loffert. Jeff Loffert, get in touch with me. I have a prize for you. Jeff was the 31st entry into our contest. His guess of 384 boxes was off by 12. And he did a great job. So, Jeff, I guess I have to give you the same 2 weeks, but get a hold of me. We're getting right into the holidays. If you get a hold of me quickly, you could have this under your tree or other, plant. I don't care. Okay. All right, Jeff Loffert. Well, congratulations. Please give us a call on all the usual channels. Zap Consulting. Welcome aboard, sir. So, got the contest winner out of the way. The Sharpie of Fame will check that off. So let's quickly talk about back orders. So, I've been making stones now for 3 years. PFG stones are all over the world. And I have never quite had back orders from my supplier, which is Norton. I get the stones from Norton, only Norton, and I grind them. And the 4-inch rectangular stones, which happen to be the most popular stones on the planet, are now back ordered. I was supposed to get them last Tuesday. They did not come in. Fingers crossed that they come in this Tuesday. I increased my safety stock numbers, and we will be well stocked once they come in. But there's one order waiting on 4-inch stones. I managed to get all of the other ones out. So we have some back orders. It's not too bad. Next up for this weekend is minis, and I'll be able to bang out 2 out of 3 of the orders. And then one of the orders needs a NOS. You know who you are. And I have to get that going because then they're not in inventory, but I have to produce them. So that's the back order situation. It's not terrible, but it was weird because it's never happened before. So, does anybody have any questions that are related to that are not related to chuck grinding, because we're about to get into that. You could put that in the chat. Oh, I should point out, which I'm pointing out now every time we chat, is I really would like more people to move over to YouTube Live, because eventually we're going to have to go YouTube only, because if I want to have guests, I'm going to have to do that. So I'm sort of encouraging everybody to get ready for that. All right, let's clear the decks and let's talk about grinding chucks. One of the challenges with grinding chucks, as you know, well, let me back up even further, and maybe this is sort of beginner's corner also. One of the very few, if not the only, machine tool that we have in our arsenal where it cuts its own work surface is the grinder, is the surface grinder. And Chris, the pragmatic machinist, who I haven't seen show up yet, asked me the question, well, can't a mill its own table? And that was a really interesting question that is worth thinking about. The short answer is theoretically yes, practically no. So I know that some people get their Bridgeports set up and maybe the slots got mangled by somebody, and they can go in with an end mill and they can recut the sides of the slots on the top of a Bridgeport table. That's a good example of a machine fixing itself. And Brian, hello. I didn't say hello to Brian. Craig Camp, welcome aboard, sir. Metric or imperial, you're funny. But if you said, I'm going to take my Bridgeport and I'm going to cut the table with the Bridgeport, my opinion is that it's not going to work very well, because you're actually cutting a cast iron table and the machine isn't that stiff. So it's not going to go as well as if you used the other processes. Whereas in a grinder, we grind our chuck, that's de rigueur, right? We always grind the chuck. So what does grinding the chuck do for you? Grinding the chuck makes the chuck parallel to the ways. And I think that's a very important thing to remember. Does it make the chuck flat? No. It may, as a side effect, make the chuck flat, but it will copy the ways up to the chuck. So if your ways look, well, like a smile, okay, your chuck is going to look like a smile. But if your ways are beautiful and dead flat and gorgeous, then your chuck is going to be beautiful and dead flat and gorgeous. So it's copying the shape of the ways onto the chuck. I think that's a really important distinction. So for the remainder of our discussion, yeah, we'll talk more about this metric, Chris, about using your mill to fix your mill. Every rule has an exception, and every exception has a rule. And I'll grab a tool to show you something that I've done. What if you have a tooling plate? Like a lot of times, like for example, this looks like a setup. It's not a setup. This is a 6-inch tooling plate that I made. I made a pair of these guys, and they're wonderful to use because you could pop them into a vise. So let's say you're doing something super critical, and you bolted this down to your table, and you came in and you did a skim cut. That's an example of in a mill, flattening the surface for precision in that area. Again, you're going to copy the ways up to the part. But that's an unusual occurrence, whereas in a grinder, in a surface grinder, this is what you do all the time. So the act of grinding the chuck is very important. Now, when you're installing a chuck, or you're servicing a chuck, or you're refurbishing a chuck, there's other things you need to do. I recognize that. Okay, there's preparing the table. You may have to grind the actual table of the mill. You may have to then take your chuck, flip it over, grind the bottom of your chuck, then put it down, and then grind the top surface of your chuck. I recognize that. We're not going to talk about that today. Okay, and I went through that. If you look on my website, I did posting on that when I was restoring the MicroMaster. But I don't want to get into that. Yeah, Bart says also grind the table of the grinder. The ways are much longer. Mill normally doesn't have the travel to cover the whole table. This is all correct. So I once, a while back, I can't show it to you because it's frankly very big and heavy. I made a big aluminum plate that goes in my vertical machining center, and I filled it with 1/4-20 threaded holes for tooling, for holding down tooling. So let me just show you the tool that I had to make in order to do that. Let me go grab it. So if you've been following me a long time, make sure Bart says make sure you buy a larger grinder than your mill. That works. Hey, Orange Vice, welcome aboard, Eric. Speaking of larger grinders than your mill, Eric has a larger grinder than everybody's mill. So in order to make that aluminum, the big aluminum tooling plate, I made this fly cutter, which, there you go. Okay, so this fly cutter is about 12 inches long. It's a bar of steel, which I left symmetric for obvious reasons, for balance. And there's a nice cutter, custom ground from the remains of an end mill. So it's a high-speed steel, round nose cutter. And this goes into the VMC. And I remember that 200 RPM is where I run this thing. So you run this thing at 200 RPM, and I can traverse all the travels of the machine over this plate, and I get this much more cutting, right? I get this cutting outside of the limits of the machine. So that's why I made this, and it covers a really nice work area, and it's really does a great job for flattening out this plate. So this was my my fly cutter from hell. There you go. And that's a good example of a machine machining its work surface. But again, that's relatively unusual. I got to put this down. By the way, if you want, if you're looking for tooling plates, go no further than Saunders Machine Works. They make some wonderful product. But we're back to the grinder. So the grinder has to grind its own chuck. And here's the problem. It's a soft material. All of it is a soft material. It's either, there's different flavors. There could be aluminum and brass. I'm sorry, aluminum and steel, steel and brass. And mine happens to be brass and steel laminate. So the steel plates are the poles, the magnetic poles, and the brass is the non-magnetic material. So you have two very different soft materials. One's ferrous, one's non-ferrous. They're both soft, and we're going to grind them. So grinding soft materials sucks from the beginning. Unix Carbide, welcome aboard. Mech Everett, welcome aboard. So we have to take considerations for grinding soft materials. I mentioned in an earlier chat that I discovered a Norton document. I have not found it yet. I'm working on it. It was a one-pager from Norton on how to grind your chuck, and it said, amongst other things, it said to step over 1/2 the wheel width, and I've advised that previously. In a discussion with Robin Renzetti, who you should follow, he said, go a full wheel width. So I understand why he said that. I ended up going a 1/2 wheel width, and it worked out pretty good. And the reason is this. What I considered the prime enemy in grinding the chuck I had in my head was wheel loading, meaning you're grinding this soft material and it's soft. It's smushing up into the wheel. It's not forming a chip that's flinging out. Robin suggested that that's not the number one enemy, that the number one enemy is actually wheel wear. And I'm starting to understand where he's coming from. So that may be more important than loading. For the moment, let's just smush them together. So you're grinding this wheel. It's a big area, right? And you're grinding from one end to the other. And what I experienced in my early days with the Harrig, the manual Harrig, is that I would get a good grind, and then as I got toward the end of the work, it started failing to cut, which I was eventually attributed to loading. Robin is suggesting that might be wheel wear. Doesn't matter. We got to get rid of that. So by stepping over a 1/2 wheel width or more, we're getting across that thing fast. What do you trade off for doing that? You trade off the fact that you're imprinting the shape of your wheel, the shape that's on the bottom of your wheel. You're imprinting that, every time you step over, and you're not averaging by doing a lot of small step overs. So we don't care, because we're going to dress our wheel, and then we're going to go, and it doesn't have to be beautiful, okay? It just has to be flat. So that's the first element of chuck grinding, is that you're going to be doing this huge step over, okay? It's not like you're finishing some tool steel surface and you want it to be a mirror where you're going to have teeny step overs. You're going to have great big honking step overs because you're running from the two guys chasing you. One guy's named loading, one guy's named wheel wear. Okay, and you're trying to get across that table as fast as you can before they catch up with you. When I figured that out on the Harrig, and that it was from that ancient Norton one-pager copy of a copy of a copy, boom, I started getting a flat surface, an ugly flat surface. Which brings us to our next point: is how do you dress the wheel for grinding the chuck? So I played with dressing speeds. Now the really super nice thing about the CNC grinder is everything has a number, okay? Except for one thing, which I'll get to. Everything has a number, so we can record the numbers, and if we use the numbers next time, it's going to be the same. Whereas when we walk up to our manual surface grinder, frequently we don't have numbers on everything. It depends how the my left shoulder's remembering. It depends how the left shoulder's feeling today over here, and how the tennis elbow feels like over here, and that's going to change your rates and stuff. So we don't have numbers. Well, the Okamoto is a robot. If we have numbers for stuff, it's going to do what the numbers say. So that's great for repeatability, but it's also great for communications. I could give you a process, and you could go duplicate it. So even if you're on a manual machine, I could give you these numbers, these speeds, right? And you could do some, get your stopwatch out and do some timing and figure out what it means to achieve those speeds. So keep in mind, these speeds are actually pretty important. So for dressing the wheel with a single point diamond, my normal number is 20 inches a minute. So for grinding the chuck, I cranked that up. I cranked it up to 30. I didn't think it was an open enough dress. I cranked it up to 40, so it's 40 inches per minute. So that diamond scoots across that wheel fast enough that it's almost cutting a thread on the wheel, okay? This is desirable. We have a name for this in surface grinding. It's called an open dress or a fast dress. And a fast dress isn't very, it's descriptive of how you get it, but it's not descriptive of what it is. An open dress sounds a little better. Bart says, does a big step over give more heat? That was my biggest problem. I used small step over. Okay, so if you had to name another enemy of grinding the chuck, it is heat, okay? So let's finish the dress, and then I'll talk about heat. Yeah, and Bart says, at that time, I didn't have the coolant set up. You are anticipating me, sir. So we get that dress nice and rough. So my programming for that mission was 2 dresses at 40 inches a minute. By the way, all of this is in the video I put on YouTube, so you don't have to like write anything down while you're driving, okay? 2 dresses at 40 inches a minute, each taking 1/1000th. So bzz, that was a 1/1000th cut. Wheel comes down, bzz, another 1/1000th cut. That was the dress on the wheel. The dress is very important because it has to be an open dress which is optimized for a soft material. Now, let's talk about thermals. If you try to do this dry, first of all, you're gonna completely fail. That's the first thing you need to know. But if you're gonna try to grind this thing dry from a thermal point of view, what happens is you're generating heat, and you're actually a full width grind on the wheel or half width grind on the wheel is generating a lot more heat than normal. Yeah, so Henry says, I guess grinding dry is not really the best idea to get a really flat surface. Maybe. I'm glad you said that because you're thinking the right way. But let's just talk about this. So, as you're traversing the wheel, you're depositing heat into traversing the wheel. As you're traversing the chuck, or the work, any work, you're depositing heat into the work. No way around it. So, what do you do about that? Well, you could take off very little material and generate very little heat. That is an approach. So, you take off very little material and you go back and then you take off very little material. Yes, that is an approach because it gives the heat time to dissipate. Whereas if you just go in and you say, I'm going full width, then the heat doesn't have time to dissipate, and the heat is going to cause, the heat will always cause the material to grow. Well, where is the heat concentrated? In the center of the work. So the center of the work is going to grow more than the edges, and now you're going to cut it, and then it's going to cool off and go back, and what happens is you get a dish in the middle of your chuck. It could be pretty significant. So heat is the enemy. So what you want to do is the open dress is part of reducing heat. The open dress is part of reducing heat input. So you want to go open dress. You want to go a small depth of cut, okay? Yet you have to have a high width of cut because you want to get across the work before the wheel goes bad because of wheel wear or loading. Okay? So keep that in mind. So what do you do about the heat? Number 1, don't take a lot of material. Number 2, open dress. Number 3, coolant. And I hear what you're saying. I don't have coolant on my machine. Okay, so if you have a surface grinder, probably a manual surface grinder, and you have no coolant capability, you're going to have to add it. I was recommended that to use Crisco, okay, which is a hydrolyzed oil. It's used in cooking as a replacement for lard or animal fat. It's a poor replacement for lard or animal fat, but it's a replacement. So the number one use for Crisco in our house is me going to the kitchen and borrowing the Crisco and putting it on a chuck. So that's what I did when I had the Harrig. I took Crisco and I smeared it on the truck, and I went ahead and I did my grind, and after a pass I would smear more Crisco on the truck. Another probably better approach, I'm giving you coolant alternatives in increasing order of desirability. The second way would be WD-40. As I've said, WD-40 has a number of really excellent uses, none of which are lubricants. It's a terrible lubricant. And it's a terrible rust preventer, but it's good at a lot of other things. And this is one of the things which it's good at, is being a coolant. Like on the lathe, using it for turning aluminum, it's awesome. Well, similarly, using it as a coolant when you're grinding aluminum or soft materials, this is the place you want to get out your can of WD-40. Which German word did I use? Which, you gotta, Henry says, funny how you use German words like they were English. There are a few in my language. Which one did you hear? I have to know, because I don't know which one I used. Oh, schmearing. Yes, you caught me, Henry. That comes from the Yiddish, which comes from the German. To schmear. A bagel with a schmear is cream cheese on a bagel is a schmear. So yeah, you caught me. This is not the first time, and this is not the last time you're going to catch me on this. Yeah, you're funny. So, okay. So Crisco, check. WD-40, check. WD-40 is great because it's relatively cheap, and you can have it ready. Yeah, Bart says, it took me 4 hours and not fun, but it got done. But installed the coolant the week after. Without coolant, I would use a coarser wheel. Yeah. So, all true. So where are we now? We're at WD-40. The next thing, which is Bart used WD-40, and the fact that it took you 4 hours is not is not a surprise. I took an hour, and I put this in the video, an hour and 40 minutes was my process. But that included balancing the wheel, changing the wheel, dressing the wheel, and then finally getting it done. So still having a CNC machine that doesn't get tired helps. Fabian, welcome aboard. Bob Labs says, Schmearing the Schmutz. We don't want the schmutz. Okay. So the next thing, which I lived with for years, was the Noga Mini Cool. I can't say enough good things about the Noga Mini Cool. You guys probably know what it looks like. I'm looking at one right now. I have one on my Bridgeport, and when I had the Harrig, I had one on the Harrig. The Noga Mini Cool is a mist cooler, a mist deliverer, right? It takes you take some sort of coolant, you pipe your compressed air into it, and it makes a, not quite aerosol, but it makes a mist blowing with air. You can adjust the ratio of liquid to air. You can adjust the volume, and it has a lock line with the schnozzle, and you put it where you need it. For grinding, especially on an old, well, not necessarily old, but a manual machine that doesn't have coolant system, a Noga Mini Cool is excellent. Okay, you're done. If you have a Noga Mini Cool, you got a coolant system. Fortunately, on the Okamoto, I have full flood cooling. I have all the guards. I have the tank and the filters and all that good stuff. And man, I'm always running maximum coolant. So all of these things lead to getting the heat out, which is very important. Okay, you can get through the job with WD-40, and I got through the job with Crisco. Okay, so that's the next important part of the recipe. An important part of the recipe that I don't think we talk about much is you have to turn off your need to make the surface pretty. It doesn't matter, okay? When you go to indicate the surface, the indicator will tell you if you won or not. Now, you're going to take an indicator, you're going to attach it to the wheel housing or the wheel, and then you're going to sweep over your chuck. And you'll see I did this in the video I just posted. And the indicator will tell you things. So when I swept the chuck before I ground it, I saw the remnants of the previous grind. Now, there's a gentleman named Evan who came from Okamoto, and he was awesome. He's a friend of mine now. He might even be watching this. And Evan did a great job. And at some point, he did his normal installation thing, and he says, okay, we're at the point now where we grind the chuck. Let me show you how to grind it. And he taught me about one of the modes in the grinder, which is called traverse bias, where the table is reciprocating, but the z-axis, the motion of the table, is continuous. It's not stepping. They call that bias. And he ground the chuck using that method and using the white wheel that came with the machine. So when he was all done, it looked spectacular. And I was, yeah, this looks great. And I think we indicated it. I'm pretty sure we indicated it, and it indicated good. So Evan says, that's how you grind the chuck. I'm like, that's awesome. Hang on. And you know what's coming, right? I reach over, I get my PFG stones, and I stone the chuck. And it shows a multitude of sins. It showed wheel imbalance. It showed, you know, these big step overs, which was not a problem, but it basically showed a lot of bumping around. The biggest part of the defect in that grind was wheel balance. Now, was it okay? Yeah, I used it for a year, so therefore it was okay. But once we hit it with the stones, it was pretty obvious what was wrong. So I would strongly recommend that you have a set of PFG stones, and after you think you've done a good job grinding your chuck, you stone it and let it tell you what's going on. So in the video I just posted, you'll notice that there are these little bright lines at my step over, and they're very subtle, but they're there, and it's like, gee, I wonder what that's from. But once I stoned that and it brought those lines up, and I ran the indicators over them, you would expect, as I was going in the z-axis, you would expect to see the indicator go boop, 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 as it went over those. It did not. I couldn't see anything. Now, admittedly, I haven't put the micron gauge on it yet, but we also don't care at that level. So, again, you're not going for pretty. You're going for flat. And you're not going for smooth. You're going for flat. So if there's a little roughness, we'll use the word roughness, if there's a little roughness to the surface, that's perfectly fine. In fact, one can make the argument that getting the parts off the table is a little easier when the table has a little bit of roughness. Okay? So don't chase the same things you would chase on a part that you're grinding on the chuck. The chuck has its own requirements. So we talked about, I gave in my recipe in the video we just released, I gave my table speed. So I measured my table speed as 7.5 meters per minute. I bought one of these cheap surface speed tachometers from China that runs on a 9-volt battery, and it gives you a number. This is the one number that isn't really. I think I can get at something in the Fanuc control, but I've just been using this for so long. But now you have a number, right? So even your traverse, you have a number to associate with. What else? So in continuing the theory of minimum heat input and getting the job done, I have to switch back and forth between metric, English. Sorry, I have to just keep switching around. If I'm doing anything critical, I have to get the calculator out, though. So we're going to go down a maximum of 1/10,000th of an inch each pass. I'm sorry. Okay, I know you've just set up your chuck. It's got a 3/1000ths dish in the middle, and I've just told you've got to take 30 passes, maybe 35 passes to clean this thing up. Yes, there is no shortcut. No shortcut. Okay, so 1/10 maximum. Now, when I started on Friday, when I started, I actually had it at a 1/2 and it was pretty cool because you could see it was taking the Sharpie marks off, and the poles, right? The steel and the brass were at different heights. Think about that. So it was fun to watch, and then eventually I said, you know what, I'm going up to a 1/10. So I cracked it up to a 1/10 per pass, and it never went higher than that. And unfortunately, that's what you got to do if you're going to keep everything working. If you think you're going to rip through it at deeper cuts, I'm sorry. I apologize. Hey, Nick, welcome aboard. So, Paul, welcome aboard. So, what else are we missing on wheels? I added a good video on my grinding playlist on my YouTube channel from Solid Rock Machining on grinding the chuck. There's no surprises there. Everything we've talked about is pretty much what he does. I mean, he had a couple of approaches that are a little different, but basically the same. I really like Steve, and I think he's a good guy. So no big surprises there. Does anybody have any chuck grinding questions? I know we left out details. That's why I made the video. So up on the YouTube channel, grinding the mag chuck full recipe is the name of the video. Okay, it came out awesome, and the next step for me, I'm actually warming up to do some work today, but I might get out a much finer indicator and go over it again. Just hey Bob, welcome aboard, sir. My favorite grandmaster. Happy Sunday. So that's about it. That was my story. Let's see. Tuck says, so I don't have coolant on my surface grinder. Anything I can do with this, or do I need to spray coolant on the chuck when it's grinding, or am I doomed? No, Tuck, you are in fact doomed. Listen, you live near Buffalo, New York, and you're asking me if you're doomed. Do I have to even answer that question? No, you're not doomed. I think we covered it. Like I said, a healthy spray of WD-40 on the chuck, then grind, and then for your next pass, a healthy spray of WD-40 on the chuck. So it's all wet. Same thing with the Crisco. If you want to use the Crisco, just put some on your fingers, smear it, and that was for Henry, and go. And then but before the next pass, you do it again. So you don't have to stand there with the can of WD-40, but you do have to soak the top. But Tuck, Tuck says, I can put snow on my chuck if that will help. Do you have any? I think you have some. Yeah, if you could make it a little thicker, it would probably help. So Yeah, and Tuck, right now, stop what you're doing. Go to Amazon or your favorite supplier and order a Noga Mini Cool right now. Right now. Don't stop listening to me. You can watch a video later. Go order a Noga Mini Cool. It's awesome. Okay? It's the answer for grinders that don't have coolant systems. Okay? And you're going to drip stuff all over the place anyways. Don't worry about it. Okay. That's the story on the chuck grind. If you have any questions, you could pop them into the thing. Toolmaker 365 says, an old guy I worked with would grind slots in the outer edge of the wheel with a pedestal grinder to help with cooling. Sketchy Mitch, question mark? Oh, sketchy much? Yeah. He says sketchy much? Yeah, it's kind of sketchy. I would absolutely not do that. No. Let me see if I can clarify that. No. Okay, so Kevin asks, Mini Cool preferred coolant. Cool Mist 78. So Cool Mist is a nice synthetic coolant. You add it to water at 1 to 32, so it's an ounce in a quart. Did I get that right? No, quart is 16. No, 30. Yeah, ounce per quart. 1 to 32. And 78. No, a Cool Mist 78 is the light duty. Cool Mist 77 is the heavy duty. You want the light duty. You want cooling, not lubricating. Paul Morley says, I can confirm the Noga Mist is great. I have a 618 manual grinder, and it does great. Absolutely yes. Yes, 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 yes. Okay. Cool Mist 78. Cool Mist 78. I bought a gallon of it. It'll last a long time. Okay. Cool. Any other questions on that? I got some exciting things to share about Cryo. So if nothing else happens here about chuck grinding, we'll jump into Cryo. I think we did the ground chuck pretty well. I like onions in my ground chuck. You might want to try onions. Okay, let's talk about Cryo. So when we last met our heroes, we did a batch of blade-like substance and failed. And then we did another batch of blade-like parts, and they came out nice. Kevin says, let's freeze. So, trust me, we're going to be freezing. And then I did a cryo treatment as part of a stabilization process so that I could finally get the Crisco gauges flat. And they got flat. Danny Bradley says he prefers leaner, 93% water, 7% coolant. Whatever floats your boat, dude. Whatever. So we got that job done, but then I did a deep dive into Cryo, and I learned. I'm going to pull out some books here. My first exposure to cryogenics was this book. You know, a lot of us have seen this book before. This is a book by Bill Bryson, Heat Treatment, Selection, and Application of Tool Steels. Danny, whatever. Oh, you're talking about the ground chuck. No, I like it with a little fat in there. It adds to the flavor. As to the Noga Cool, how do you keep the grinding dust out? How do you keep the grinding dust out? Well, you spray the Noga Cool in the direction the wheel's turning. Okay, so the schmutz is, and the chips and the sparks are going that way, and it's sitting there spraying. There's no worries. Just let it rip. Yeah, the onions are the best. A little paprika, onions. We're talking. And if you chopped up some bacon in there, I'm not saying that would be bad. So we all may have seen this book. Pretty good book, very cookbooky, okay? Which is great because it gets the job done. And he must have sold a zillion copies of this book. So in the book, you'll see a lot of charts like this, okay, which is your heat treatment and hold, and then go up to the austenizing temperature, and then quench, and then temper, and then down, okay? No, you don't recycle the cool mist. It's gone. Yes, Henry is correct. You can use bacon lubrication also. Just take some bacon and rub it on the chuck. No problem. Make sure the door's locked, though, because the dogs are going to come. Municipal water. Welcome aboard. Some of the jokes here might be all wet. Stoke machine. Welcome aboard. So we're familiar with the basic heat treating of steels. And with the A2 steel, it's an air quenching steel. So you bring it up to temperature, you give it a soak, and you yank it out and let it cool in air. And then you go into your temper and you're done, right? Almost. So in Bryson's book, he talks about cryo treating, and he talks about cryo treating using dry ice. And that was my first experiment. Oh, look at that. There you go. That was my first experiment with heat treating. And it worked. It worked great. It was awesome. Dry ice was a big win. So then I bought Bryson's second book, aptly named Cryogenics. This was an okay book. I learned some things. Not as good as his first book. And you'll note that in the Cryo book, I had a bookmark, and it looked like that. Hello. Bueller? Focus? Focus? There's a guy in charge of focus. His name is UFAC. Focus, UFAC. There we go. Okay. Does that look familiar? So that was my plan. And what's important about my plan here is that it was go to, the high temperature, come down, temper, then go down to minus 320, right? That's the temperature of liquid nitrogen, and then go up to 300 and then done. So this was my picture of proper cryo treatments back a while back when I read this book. Then I went ahead and I played with dry ice. It was a win, measurably a win, okay? Then time passes and I don't do much heat treating for quite a while. AVE, is that like Avenue or Ave Maria? I don't understand the reference. Let's see. Welcome aboard. So then I buy this book recently, and I've been, Henry, are you paying attention, Henry? I've been kvelling about this book called Knife Engineering, okay, by Dr. Laren Thomas. Okay, I talked about his YouTube channel, knifesteelnerds.com, and Knife Steel Nerds is his YouTube channel. So, Henry, you really think I don't know? I know. But now I will read you. I'm going to read you a quote. Pay attention. This is on the final exam, okay? I'm going to. Wow, Bob Labs, you also think I've been living under the couch. Listen, I get around. I know what I'm talking about. Okay. Here's a quote from Bryson's Cryogenics. Are you ready? It is wrong to apply a cryogenic process directly from the quench it is uncertain who came up with this very bad and dangerous theory. I won't read anymore, but you got it? So my picture, which I drew in his book, conforms to his theory of you do your quench, you do your temper, and then you can go off and cryo. Hey, Paul. Weren't you over there? Then I get this book, more recent book, from a gentleman who is, as his name implies, a knife steel nerd. And I will now read from this good book, which you could tell I've been paying attention to. The time in between the quench and the cold treatment also matters. The optimal process is to have a continuous quench to the cold temperature. When there is a delay in time, even at room temperature, the retained austenite stabilizes and the cold treatment becomes less effective. So let me summarize this for you. Bryson says quench, temper, and then go do your cold treatment with some strong words. Okay? Thomas says quench and continue your quench all the way down to your cold temperature, then come back up, then temper. So what is a guy to do when he has two experts in violent opposition to each other? He gets on the thing. He gets on the doobly-doo, just in case you're wondering. And that's what I did. So I was in contact this morning with Dr. Laren Thomas, the knife steel nerd, and he said what any expert would say, which I've said to others. He said, "Didn't you watch my latest video?" And I, felt like a jerk. And I said, well, I did watch your latest video, but I still don't know. So we talked. Basically, he explained that, no, his words were absolutely clear. You quench, and then you get into your cryo, and you continue down, and you do it soon. So the point he makes in the book, with numbers, okay, and data, due to Roberts in 1980, if you're using liquid nitrogen, you have about 1 hour to get it into the cryo before changes start happening that you can't recover from. So, and for dry ice temperatures, that time is even shorter. And here's the kicker. For room temperature operations, in other words, no cryo, you cannot get complete conversion. And your retained austenite will forever be no better than, well, I'll give you a number. No better than, in the neighborhood of 13%, 10% retained austenite. Okay, so the cryo solves the problem, but the time is also a big factor, huge factor. So my new process is, and I confirmed this with Laren Thomas live this morning, and he said, yes, that is correct. My new process is quench, get into cryo, go all the way down, soak it, come back up, temper it, and there you go. Bart says we're one of the few communities where the word nerd is a compliment. It's actually a requirement, I think. So that was a big lesson for me this week, and I am really looking forward to doing it. So Bart, you are a nerd. If you're here, you're a nerd. So I will show you some goodies here. If you want to join me on this journey. I bought a 10-liter liquid nitrogen Dewar from Amazon, intended for freezing semen samples. No, I don't intend to freeze semen samples. But there's a whole category of products for that crew. And this is one of them. And this was a small Dewar. I've talked to other people who have bought the 20-liter Dewar. Okay? And they come with these things, right? You put your samples in there, and you can lower it into this relatively small hole, and then it kind of hangs on the lip, and then you could put another one down there, and you could have 6 of these in there. Now, these were a nice size because for knife steel applications, it was kind of perfect. And then you would lower it down. I can't demonstrate. I can't. It's going to be hard for. Oh no, actually, I could demonstrate. So you take your steel sample, okay, and you put it into there, right, and then you lower it into the liquid nitrogen. I'll do that right now. I'm taking out the cover. It's smoking. I'm lowering it in. There's some bubbling. It's pretty cold. All right, so we have our sample, which looks like this, down in the liquid nitrogen. Okay, and that's cooling off. And we'll see how it comes out. Make sure when you're handling liquid nitrogen, by the way, you're wearing eye protection and gloves. Oh, crap. Well, yeah, more or less. While the sample is cooling off, I wanted to show you. So I ran into the question of how am I going to measure the how much I have left, and the answer is weight. Well, I didn't get a tare weight on my container before I had it filled. My bad. So I bought a dipstick. So apparently there is a liquid nitrogen approved dipstick, and you dip it in and you pull it out, and then frost will form and tell you what depth your liquid nitrogen is. I am here to save you guys. Hang on. I am here to save you guys $29.99. Okay? This is a piece of plastic. It is probably PVC or ABS. I don't think it matters, but it's black plastic. Black probably matters. It's a little under 1/8 of an inch thick, and it's about a centimeter. It's about a ½ inch wide. Okay, and it's graduated. 30 buckaroonies. I consider that tuition. Then I pulled off my stock rack a piece of nylon, black nylon, works great. So even could drop that. Is this 1/4 inch? No, it's bigger than 1/4 inch. I would go 1/4 inch or 3/16. 3/16 piece of nylon rod, black, totally fine. Okay. Yes, exactly correct. Henry says liquid nitrogen will instantly boil on your skin and will not burn you because of the Leidenfrost effect. Who's using German words now? Leidenfrost is actually the name of the guy who came up with it, and that is true, but you still have to be careful. You have to be careful. And I'll tell you, you have to wear your safety squints. All right. So that's how to save 30 bucks. You're welcome. And then I go over to Airgas, which is my supplier for my gases for welding. They also are my Norton dealer, so I give them a lot of business. And now we're doing liquid nitrogen, and I'm very happy about that. They're very careful about who they sell to, by the way. So don't be, if you go to your local supplier and they give you a hard time, don't be alarmed, be persistent. And you have to be able to transport it outside the vehicle. So in my case, I had one of these storage racks or transport racks that go into my trailer hitch. Plus I have a trailer. Yep, you gotta be careful. Yes, Bob Labs correctly points out another scientific principle that we must not confuse the two, which is the Lederhosen effect. Yeah, let me pull out our sample and let's see how we're doing. I'm opening the hatch and pulling out the insulated plug. The sample is coming out of the liquid nitrogen. It's coming out. I said out. Why is it getting out? There we go. I'm closing the hatch. Very crackly. I'm going to dump out the contents. Oh, there it is. Get rid of that. This is crazy. It's cold. Too cold. Will it smash? Whoa! Holy heck, it smashed. So it shatters pretty nicely. I'm gonna give it a minute before I pop it into my my face hole here because it is cold. But there you go. It's harder now, but will it be more wear resistant? I will let you know. If it's very wear resistant, you got to be careful because it's still pretty damn cold. So I'm taking the little pieces, which have warmed up a little. Still some crunchy going on there. So thank you for joining this episode of Freeze Everything. Okay, Bonk, you just showing up? Dude, there's going to be an exam. You didn't... This was our liquid nitrogen test. And you're just showing up. Okay. So I'm happy to report that was a success. So, you are now updated on my thoughts on Cryo. So, you actually do need to temper before use. If you do this, by the way, be really careful. Because some candy bars have a pretty high moisture content. And they will stay cold. And your tongue will stick. Keep your Twix in a vice. Thank you, unconformable coating. Keep your Twix in a vice. Yeah, we'll do a... Tuck wants to do a will it smash for each candy. All right, this is ridiculous. This behavior is totally uncalled for. You're welcome. On that note, let's see, did we do everything? We did everything. So I'm taking some homework away. I will measure the RA on the chuck for you. I'll do that like real quick. So there'll be a post on Instagram within, 10 or 15 minutes. And I will report back so that you can have an RA number to go with what you're seeing in the picture. And not that I think it's critical. And there you go. I'll see you guys next week. Stick around. There might be a random live while I do the hardness, the surface roughness test. So if you want to stick around for that, but officially we are going to wrap this up. We'll see you guys next week, and go out to the shop and go make something. At least sweep up. You want to. See you guys next week.